In this video, we are going to replicate the regression of math function Java example that is bundled with the Deeplearning4j example list. The example performs these 4 steps. It first creates the data for the function y equals sine x over x in this interval, minus 10 to 10. And then it builds a neural network with 2 dense layers, each layer containing 50 nodes. Then it trains the machine and plots the original and predicted values. Let's skim through the example and see how the Java code works. This example is written by Alex Black. The first few lines create a table with values of x and y. And here's how you can, as you see, the method that creates the values of the function. And as you can see, it's sine x divided by x. So in this, the example creates 1,000 different samples, starting from -10 to 10. And then the network is created. The network has 2 hidden layers. Layer 0 is a dense layer with number of hidden nodes equals to 50, as you can see here. And then the second hidden layer also has number of hidden nodes to be exactly as 50. And then the output layer, well, the output layer basically has one output node. And then if you go back to the code, the network is created with the configuration, and it's then trained, and at the end the example plots the actual function and against the predicted values. In this small for loop, basically data is saved while at certain times of training, so that we can see how the accuracy is progressing. So I'm going to run this code, and if your code needs to download something, it's going to download it because it's a Maven project. And if you wait for a while, you'll see that the training has started, and this is the error reported every 100 iterations or 100 epochs, and it's going to take a while, so I'm going to stop recording and come back when this is done. Alright, we're back. The code took a few minutes to execute and finish the execution. As you can see, the error is quite small, 3.8 multiplied by 10 to the minus 4, and here's the plot that it produced. As you can see, the original function is in red, and the code took 4 snapshots of the predicted values during the execution. The last snapshot is shown in pink here, and as you can see, the pink is quite close to the actual function. Now let's replicate this in the KNIME Analytics Platform. So I'm going to start up KNIME, and I'm going to start a new project. Let me call it Regression. And I'm going to replicate the exact same algorithm that had in the example. So the first thing we need to do is create a table with the data set that has the values of x and y within this interval -10 and 10. Let's do that. So the first thing I need to do is create a table. So I'm going to use a table creator node, and in the configuration I need 2 columns. The first column is going to, I'll call it x for the value of x, and it's going to be a type double. And the second column, I'm going to call it sine x div x I forgot to change the type to double, and we're ready. If we execute this node, you're going to see that there is a small warning that is thrown. Node created an empty table, and that is exactly what we want. The next thing we want to do is add a few empty rows. So I'm going to use add empty rows node and configure it. I need to add 1,000 nodes exactly as the example, and we're going to fill it with zeros. Click on OK, and right mouse click and run, and we look at the data, and we've got 1,000 empty rows. Then we need to fill it with the values x and sin x by x. So the easiest way or the fastest way of doing it is using a Java snippet. So I'm going to add a Java snippet, and we're going to write a small Java code. And the first thing we're going to do is declare some variables. So I'm going to declare double x value equals, we start with minus xd, and we're going to increment with the value of 20 divided by 1000 d. And in the code here we are going to output. So we're going to add an output. No, not the input, sorry, the output. Let me just, we're going to go over here, remove this. Yeah, we're going to add an output, and the output value, we are going to replace the value that's in x, and the type is double. See, okay, so it will automatically give that variable a name, and in the x we're going to put the x value as it is. Now x val with a v, not a c, and I'm going to create another output, and I'll call that output, I'm going to replace the sin x divided by x, which is also of type double, and it's going to be containing the value of sine of x val divided by x val. And of course, once we this code is going to be executed row wise, so once we're done with the row, we're going to increment the x val by this increment value that we have over here. So let's click OK, right mouse click and execute, and let's look at the table. And for sure the table starts with minus 10 all the way to, well, just before 10, and the second column contains the value, the y value or the function value, which is sin x divided by x. Next, the last thing that we need to do in preparation is preparation of the data is to shuffle the data. So I'm going to add a shuffle node, connect it, double click on it, and use a random seed. OK, right mouse click and execute, and then look at the data, and we've got the shuffle data ready for us. Now that the data set is ready, let me put it aside, and we'll start to build the neural network model. Since I'm going to use the Deeplearning4j integration, let me go to the KNIME Labs and Deep Learning, go for the layers, and let's start with an initial empty model. Nothing to configure over there. Then, as we see, this is the network that the code builds. So after the input layer, we've got two hidden layers with 50 nodes. These are dense layers. So back in KNIME, let's go to the perceptrons, and we create a dense layer. This is the first layer, and we want 50 neurons. Let's put the um, the um, the learning rate to be 0.1, and we're going to use Xavier as the initialization weight, and we're going to use the tan hyperbolic for this first node. Now the same thing for the second layer. Let's create a I've drag in the second layer, and we do the same thing. We need 50 nodes, and let's put the learning rate to 0.01. The initialization strategy is Xavier, and tan hyperbolic for the activation function. There you go. Our network is ready now. So next we're going to train. So I'm going to go into the node repository under the learn and the supervised. We've got two learners. This is a regression, so I'm going to drag and drop the regression node and connect the data and the model to this regression node. And let's look at the node configuration. Let me just resize it like so and configure it according to the example. So for the learning parameters, the number of iterations is 1 according to the example in the Java code. You can go to Java code and look at it. We can use a random seed. In the Java code, the random seed was 1, 2, 3, 4, 5. Of course, we're not going to touch the global parameters at all. For the data parameters, we can follow the example by putting the batch size to 100, and we're going to have 2000 epochs. For the output layer, again, let's reduce the size of learning, and we're going to use the identity with for the weight initialization strategy with mean squared error as the loss function. And for the columns, this is regression, so we need to identify a target column and a feature column, and the target column is sine x divided by x, whereas the feature column is x. They need to be mutually exclusive. And we're done. The learning is going to take a while, so I'll start the execution and let's see how the learning is going. It's going to initialize the DL4j engine, and we're going to see the execution starting very shortly. Come on, come on, come on. There, and there you go. And the loss function output is here on the screen. As you can see, the error is reducing. It's going to take a few moments, so I'm going to pause the video over here and come back when it's done. And we're back. The execution finished, and 2000 epochs were completed, with the error reaching to 4.8 multiplied by 10 to the power of minus 4, which is not bad, very close to the Java code. Let me put the Java code. The Java code reached to 3.85 multiplied by 10 to the minus 4. Now that we have a learned machine, let's go for the prediction, and we've got a couple of predictors here. We want the regression predictor, and so I'm going to connect the regression put the regression predictor on the screen, and I'm going to connect the model. Plus, I'm going to take the same data and connect it to the predictor and execute. As you can see, it executed very quickly, and the model is ready. Now we want to plot. So in the KNIME Analytics Platform, there is a line chart, J-free chart. Okay. J-free chart. There is a line chart. Yep, there you go. So there's a line chart, and we can just give it the data. Oops. And all we need to do is configure some options. So we want to include the sin x and the prediction, and on the x-axis we're going to use the x value. For the axis configuration, just for labeling, we're going to label x and let's say sine x over x, and we ask it, now we can configure it to show the color. Nothing over here. Okay, we're done. And let's right mouse click and execute and view, and voila, there you see the actual function is in red and the predicted one is in blue, which is quite close to what we've done. If I bring the output that was produced through using the Java program, it is very similar. The results are very similar. Now let's have some fun. Just for the fun of it, let's change this this model of the network into the following. Instead of having, let me go back to the previous slide. Instead of having 2 hidden layers, let's go and have 4 hidden layers. The first one having 50 nodes, the second one having 40 neuron nodes, the third one having 30, and the fourth one having a 20. So it's like a triangular shape, if you can imagine it, like a triangular shape model for the hidden network, and see how it works. Why am I doing that? Just for the heck of it. Since if we can do it, and we've got the KNIME Analytics Platform, which makes everything so easy, so let's do that. So I'm going to take these two and disconnect them from the network, just put them on the side so this model is saved for me, and go into the KNIME labs, deep learning, and the layers, and I'm going to drag 4 layers, dense layers, 3 and 4, and let me just put them side by side and connect them and configure each one. So the first one is configured to 50 nodes. I'm going to use 0.01 as learning rate, Xavier for the initialization, and 10 hyperbolic for the activation function. The next will have 40 with all the same other parameters. The next one with 30 nodes but the same parameters, and 10 hyperbolic. The last one is 20 with the same parameters, which includes 10 hyperbolic for the activation function. And let me just move these nodes a little bit forward. So I'll connect this new model to the predictor, and I'm going to run the predictor. Sorry, the learner, my mistake. And there you go. Here's the progress of the learner. Again, it's going to take a few minutes to execute, so I'm going to stop the video and come back when it's done. And we're back. 2000 epochs have finished, and the error is 8.3 multiplied by 10 to the power of -5, which is a much better fit than previously. And let's run the predictor. Look at the data, and there you go. The predictor populated this third column with predicted data, and let's execute and see how the fit is. And as you can see, this is a much tighter fit when you compare the predicted values in blue against the actual values of the function in red. So there you go. We have taken an example from DL4j, which does regression of a math function, and we replicated in the KNIME platform. Thank you for watching.